Good day, everyone. I am Bianca Migliara, together with my group mates Joaquim Marcelada and Carla Cacho. And today we're going to talk about our group's report on the bioinformatics of collagen. This will be the flow of our report. We're going to start with the introduction, followed by the blast and output, followed by the nucleotide sequence, blast P, protein structure, protein characterization, and lastly, gene characterization. Let's first start with the introduction. First, let's start what collagen is. Collagen comes from the word koila, which means glue in Greek. Collagen is also found in many other parts of the body, including blood vessels, corneas, and teeth, and this is where it acts as a glue. Collagen is the most abundant protein in the animal kingdom, accounting for about 1/3 of its protein composition. It's rigid and resistant to stretching. Collagen is a hard, insoluble, and fibrous protein. In addition, in most collagens, the molecules are packed together to form long, thin fibrils. These act as supporting structures and anchor cells to each other, and they give skin strength and stability and elasticity. The cofactor of collagen is vitamin C. Vitamin C is essential for collagen synthesis and maintenance. During the post-translational modification, the lysine and proline residues get additional hydroxyl groups added to them via hydroxylase enzymes. These produces prolyl hydroxylase and lysyl hydroxylase. Prolyl hydroxylase stabilizes collagen while lysyl hydroxylase gives structural strength. Vitamin C also acts on the DNA to increase transcription rate, resulting in the more stabilized pre-collagen mRNA. When there is a deficiency of vitamin C, pre-collagen transcription decreases, and the person may be diagnosed with scurvy. In scurvy, collagen is inhibited by vitamin C deficiency, resulting in defective collagen formation. Symptoms may be anemia, myalgia, bone pain, easy bruising, swelling, petechia, gum disease, poor wound healing, and depression. It is mostly seen in infants, elderly, alcoholic, and those with inadequate intake. The function of collagen depends on its type. There are at least 16 types of collagen, but the most common type are type 1, 2, 3, and 4. Type 1 makes up 90% of your body's collagen, and it's mostly made of densely packed fibers. It provides structure to skin, bones, tendons, fibrous cartilage, connective tissue, and teeth. While type 2 are more loosely packed fibers, and it's found in elastic cartilage, and it cushions the joints. Type 3 supports the structure of muscles, organs, and arteries, while type 4 are found in the layers of your skin and helps with filtration. To discuss the next slide, we have Carla.
Collagen is commonly is used in biomaterials and cosmetics. Most medical application of collagen is used in scaffolds, as it gives notable binding reactions with epithelial cells and fibroblasts. Epithelial cells are the cells that line the surface of the body. It is also useful for healing wounds, as it induces platelet aggregation. Now, the stability, mechanical strength, and ability to engage in specific biomolecules of collagen are key factors to the formation of structure-based drugs. Here are some factors that may affect the said factors. First is that hydrogen bonds affect the stability of structure. Second is that the substitution of lysine and D-alanine or D-serine is said to stabilize collagen, but can actually cause the mutation of the collagen gene. And the last is that incorporating translational modifications to a heterologous collagen is unideal. Now for the next slide is to be discussed by Bianca Migliora.
Now we proceed with discussing the blast end of collagen. Here we have the results of the blast end interface of NCBI. To be specific, we'll be dealing with the mRNA of Homo sapiens as seen in the emphasized box. Our group chose the first result as it has the highest score, an expected value of 0, identity match of 100%, and a gap of 0, indicating that this shows the most significant alignment match. This shows the GenBank data of the blast end. The GenBank accession number of the protein is D21337. Here we can also see that it is present in the chromosome X of humans. it starts at the base 1 and ends at base 6378. This is the translated sequence, and it will be used for the FASTA sequence of the BLAST-P. Now we will be proceeding with the nucleotide sequence of collagen as seen in the BLAST-N. Here we have the start of the nucleotide sequence, and here we have the end of the nucleotide sequence. And for the next slide, it will be discussed by Carla.
This portion will contain the sequence used for the BLAST-P. Next slide, please. Here we have the protein sequence found in the XPASI translation. We use the nucleotide sequence to determine the protein or amino acid sequence. Next slide. Here is the result of the BLAST-P. Indicated here is a description of the product, which belongs to the collagen of Homo sapiens. It has the accession number of BAA 04809.1, and the amino acid sequence has a length of 1,678. Next slide, please. Now, by clicking the collagen Homo sapiens from the description portion of the BLAST-P, the paired amino acid sequence will show. And for the next part, we will be discussing the protein structures, starting with the primary structure. Next. Yeah. So we found that there is 1,678 amino acids in total, and it contains 19 different amino acids. Now, this primary structure is found in the gene and is constructed by the gene. Now, the following structure will be discussed by Joaquim Arquelada.
So for the secondary structure, collagen helix is the secondary structure of the protein collagen, which exists as the single secondary structure.
Helicoidal, however, more elongated than the alpha helix and has a left-hand orientation. The sequence of the
and usually followed by proline and hydroxyproline. Next slide, please. So the tertiary structure. For the collagen that we chose, the RCSB or PDB identification number of the collagen is COL4A6. The gene product architecture of COL4A6 is that it encodes the collagen type 4 alpha 6 isoform, which is one of the 6 major components of the basement membrane, which groups tissues and sends signals for the differentiation of the cells they support. Type 4 collagen is a triple helical molecule composed of 3 alpha chains, and the diseases related to COL4A6 are X-linked 6 and non-syndromic sensory neural deafness. Next slide, please. So for the protein characterization, next slide, please. We have Carla Cachot to discuss the orthologs.
With the help of the BLAST-P of our collagen of choice, we found that the collagen can be found in different animal species that are mainly primates, placentals, and carnivores. For the next slide, it will be discussed by Joaquim Arquelada.
Okay, so also under protein characterization, we'll be discussing PI of collagen and the other important characteristics. So the PI or isoelectric point is the pH where the molecule has a net charge of 0. The PI of collagen, as shown in the graph here, the P of PI versus hydrolysis time, this will be at the 0-minute mark, which is equivalent to about a pH of 4.7. Since collagen is an amphoteric molecule, placing it at higher temperatures will degrade asparagine groups to aspartic acid and glutamine groups to glutamic acid, which allows the amino acid concentrations to dominate, thus decreasing the PI. And the other characteristics of collagen is having a molecular weight of 300 kilodaltons, which is equivalent to 300,000 grams per mole, a length of 280 nanometers and a diameter of 1.4 nanometers. Next slide, please. So for the gene characterization, next slide. So this will be discussed by Carla Cacho.
With the help of the accession number and the NCBI search, it was found that the collagen of our choice has a gene of collagen type 4 alpha 6 chain with a symbol of COL4A6. Now for further details, it will be presented by Bianca Miliola.
No. So I'll be discussing the last part of the gene characterization. So for the primary structure, it exists to have 9 base pairs. For the secondary, we have 54 base pairs. And for the tertiary, we have 702 base pairs. So that all adds up to the structure of collagen in the primary, secondary, and tertiary structure. So thank you for listening.